So good evening everyone. Today we are going to solve GATE 2020 questions. So this is question number. Today we are going to solve GATE 2020, which is this one is question number 1, which is for 1 mark. So this is basically reduction question. So there are so this one is a conjugated ketone group, which is reduced to an allylic alcohol. So we have 4 reagents, which is hydrogen, palladium and charcoal, hydrazine in the presence of alcoholic potassium hydroxide, sodium borohydride in the presence of CeCl3 and water, and lithium in the presence of liquid ammonia. So when we use the first reagent, so hydrogen in the presence of palladium and charcoal, so what it will do, it will reduce the double bond. So it will reduce the double bond. So your product will be like this, somewhat like this, right? Okay. And the next one is hydrazine in the presence of alcoholic potassium hydroxide, which is basically a Wolff-Kishner reduction. So in Wolff-Kishner reduction, what happens is your carbonyl groups are reduced to an hydrocarbons. So it will be like this. H and H, somewhat like this. And okay, leave C. Then we come to D, which is lithium in the presence of liquid ammonia. So this is basically a Birch reduction. So in Birch reduction, what happens? Your double bond will be reduced. So the answer will be somewhat like this. So whatever we left is an NaBH4 and CeCl3 7H2O. So NaBH4 and CeCl3, it is basically a Luce's reduction. So Luce's reduction, how that will happen? So basically sodium borohydride reductions, they are done in which solvent? Methanol solvent. And you are adding CeCl3 to it, that is cerium trichloride. So first thing is cerium trichloride, it will interact with methanol solvent to form this species CeCl3, O, Me and H minus and plus. So this hydrogen is acidic and it will shift like this. And also we have your Na plus B H3 H minus, which will take this hydrogen. This one will take this hydrogen and it will result in the form of minus H2 and the formation of CeCl3 minus Na plus, okay, and OMe plus BH3. Again this will take your OMe to the formation of result minus CeCl3 BH3 OMe minus and Na plus. And there is a subsequent addition of OMe groups to form, which is plus BH minus OMe and OMe. So this trimethoxyborohydride species are the active species which are responsible for reducing, and these are the main used for reduction. So now when we take a conjugated carbonyl group, suppose like this. C double bond like this. So here you have two centers, C1 and C2. These are basically the electrophilic centers where these reductions can happen. So what happens is your CeCl3 in methanolic species, it will interact with the carbonyl group, which is OMeH, to form to CeCl3, and you have your this trihydroxy species. So this one is a harder nucleophile since it is attached to oxygen. Okay, and you have this center, C1 center and C2 center. C1 is a harder center and C2 is a softer center because it is attached to oxygen. So according to HSAB principle, the harder nucleophiles will interact with harder electrophiles. So as a result, this species will reduce this C1 center, resulting in the formation of an allylic alcoholic species. So your NaBH4 and CeCl3 is the correct answer. It is responsible for the reduction of this conjugated carbonyl groups to allylic alcohols. I hope you fully understood the concept.